Hello, grade 11s. In this lesson, we'll join Vusi and his teacher as they go through problems using simple and compound decay formulae. Let's join them now.
Suppose you wanted to go to university after school. You're awarded a bursary for the fees, but you still need to get your own textbooks.
Hey, that's exactly what I'm hoping for.
Let's hope you get it. Okay, you know that you'll need about 6,000 Rand in 3 years' time for textbooks. The question is, how much will you need to invest now to be sure you have the money you need in 3 years' time?
Surely I need to know what the interest rate is.
Absolutely. There's a student savings plan which offers you 9.5% compound interest per annum. The interest is compounded on a daily basis.
But we've always had the value for P in the formula before.
Yes, but don't let that put you off.
Okay, first I need the compound interest formula.
I know the A, or final amount, is 6,000. The daily interest rate must be 9.5 divided by 365 because there are 365 days. Now I'm not sure.
Let's take it slowly. You've divided the annual rate of 9.5% by the number of days. That's still a percent. Now you need to convert that into a decimal fraction.
Oh yes, thanks.
I divide by 100 and get 0.0002602. Is this right?
All the zeros make it look complicated, but it is correct. Remember, to be accurate, you should carry on using the number without rounding it off. Now you have the value for I in the formula. What's the value for N?
365, I think. No, hang on.
It's 3 years, so it's 3 times 365. That's 1,095. So if I substitute all that into the formula, this is what I get. Wow, I've never used such big exponents before. Is this right?
Right so far. Don't forget, we're compounding daily, which is why the value for N is so big.
Now what?
How do I get P from this?
We want to get P on its own. It will help to simplify the right-hand side first.
Good idea.
I add 1 to the number in my calculator, then use the power key. The bracket gives us 1,3298.
Now to get P on its own, you need to divide 6,000 by that number.
I get 4,512.25. That's rounded off.
Well done. That's what you'll need to put into the bank now if you want to get 6,000 out in 3 years' time.
I'll have to see what I can do.
So far we've used nominal and effective interest rates to calculate interest on money. But interest can also be used in other situations. Here's a situation that's constantly in the news. According to a UN-AIDS report in 2005, it has been estimated that there is an 18.8% prevalence of HIV infection in the adult population of South Africa, and the numbers are increasing exponentially. Suppose that in a certain community of 10,000 people, there are 1,500 people who are HIV positive. Records from the clinic in this community show that each month, the number of HIV positive people increases by about 1.5% from the previous month. How many HIV positive people can you expect there will be in this community after 6 years?
Wow. 1 minute I'm working out how much to invest in a bank account. The next we're talking about the country's HIV and AIDS problem. Is there a connection? I just don't see it.
If you look at the question carefully, you'll see that the two situations are very similar. When you invest your money at a compound interest rate, doesn't your money grow by each month or even each day by a set percentage of the previous month?
Yes, it does.
Right. Now in this question, instead of money increasing, we have the number of HIV positive people in a population.
Okay, I think I get it. The formula we learned can be used in any situation where there's a compound increase.
Exactly, but make sure that you substitute the values into the formula correctly.
Okay, the value of P, which will be the principal amount, will be 1,500 because that's the number of HIV positive people at the moment. The increase is calculated on a monthly basis, so that's like compounding interest monthly. We need to divide the rate of increase by 12, right?
Just be careful here, Vusi. The rate of increase that was given to you was not an annual one. It's already a monthly one, so we don't need to divide by 12.
The value of I will simply be 1.5 divided by 100. That's 0.015.
Correct. And the value of N?
We want the amount after 6 years, but we're compounding every month.
So that's 6 times 12, which is 72 months. Now let's see what we get if we substitute all this into the formula. And substituting in all the values gives us 4,382.
The answer I get is close to half the total population of the community. It won't be long till the whole community is wiped out.
Thank goodness people now have access to ARV treatment, which gives them quality of life and many more years to live. Also, let's hope that as people become more careful, the rate of infection will drop. Even though the question was made up, it does illustrate the problem we're facing in South Africa and other areas of the world.
But 1.5% per month didn't sound like much.
Don't forget, 1.5% per month must be multiplied by 12 to get the annual rate. So, 1.5% multiplied by 12 gives us 18%, which is higher than the estimated national rate of increase. Unfortunately, this could be the rate of increase for a poor community who need better education about AIDS and HIV and better access to treatment. But then again, anyone who's sexually active needs to know what precautions to take.
Well, the math certainly makes the message clear.
Now I'd like to look at one more example that doesn't involve money. Dams. Dams are an important source of fresh water. A single dam like the Vaal Dam in Gauteng serves a large number of people. Over time, dams lose water through usage and evaporation. Unless it drains in the dam's catchment area, this isn't replaced. Suppose a certain dam with a capacity of 65 million kiloliters is losing 0.5% of its water every week. Calculate the annual effective percentage decrease in the volume of the water.
Annual effective percentage decrease? I'm lost.
Sorry, we should unpack the question first. Annual is per year or yearly. Remember what we've done with effective rate so far. We found out what amount of decrease there is in a year and worked that out as a percentage of the original capacity of the dam.
Okay, I guess we need the compound decay formula this time, and the rest of the method is the same.
Don't forget that the only difference between the formulae for compound growth and compound decay is the minus sign instead of a plus sign.
So, A is P times 1 minus I to the power of N. The value of P is 65 million kiloliters since this is the original amount. The rate of increase, or the interest rate I, will be 0.5. This is weekly. I think I'm stuck here.
0.5 is already a weekly rate, so you don't need to do any converting. It is still a percent, so we must divide by 100.
Right. Thanks.
So that's 0.005. Now what will N be?
Well, we want to know about the amount of water after 1 year. There are approximately 52 weeks in a year, so we can use N equals 52 since the amount is compounded weekly.
Okay, so now we can substitute into the formula. Let's see.
I start in the bracket, then to the power of 52, and times that by 65 million. I get 50,085,678. That's to the nearest kiloliter.
Now I'm ready to work out the effective percentage decrease, I think.
You're doing well. Now you want to know about how much the water has decreased. Then you work it out as a percentage of the original amount of water in the dam.
The decrease in 1 year will be 65 million minus this amount. That's 14,914,322. So, for the percentage decrease, I put that over 65 million and times by 100. I get 22.95%. I reckon this dam is in desperate need of some torrential rain.
Well done, Vusi. What you found is the annual effective rate of decrease. The dam has lost just over 20% of its water in a year.
Thank you for joining us for these calculations. You'll be able to practice questions like these in the Finance Growth and Decay task video. You'll also be able to learn more about finance on our website, mindset.co.za. I really appreciate your interest. Now you go and depreciate the interest. Goodbye.